Hi everyone, we'll be looking at the introduction to organic chemistry today. Now, organic chemistry is the chemistry of carbon compounds. So all the organic compound would contain carbon and one or more other elements such as hydrogen, nitrogen, oxygen, chlorine, etc. And there is a special group of organic compound that contain only carbon and hydrogen. And so they are known as the hydrocarbon. So only carbon and hydrogen and nothing else. Now, organic compounds are classified into families known as the homologous series, or we call them the homologous series. Now, homologous series is defined as a family of compound with the same general formula and they exhibit similar chemical properties. And each member of a homologous series would differ from the next by a CH2 group. And members in the same family or same homologous series will show a gradual change in physical properties such as the melting point or boiling point as the number of carbon atom per molecule increases. Now, another new term that we need to learn is the functional group. So a functional group is either one atom or a group of them that gives the compound its chemical property. So basically, the functional group is responsible for all the chemical reaction in the compound. Now, there are 4 homologous series that you will need to study in details, but let's look at some of the general things first. The first family, the alkane family, its general formula is CnH2n plus 2, where n is the whole number signifying the position of the member in the series. Now you will realize that alkane have got no functional group. But for alkane, they contain only carbon and hydrogen atoms, and all the carbon bonds are single bond. This is something that you need to take note. Okay? Now, alkene is another family. General formula CnH2n. N is also a whole number signifying the position of the member in the series. And for alkene, there will always be these 2 atoms or this group of atoms, which is the carbon-carbon double bond that is present. Okay, so in alkene, there will always be a carbon-carbon double bond. Now, alcohol, the next family, general formula CnH2n plus 1 OH. And you realize that the OH actually is your functional group, which is called the hydroxyl functional group, drawn or written as OH here, as shown. Okay, the next family, carboxylic acid. Carboxylic acid have a general formula of CnH2n plus 1 COOH. And again, this COOH is your functional group called the carboxyl functional group, or in some books, it is written as carboxylic acid functional group. Okay, carboxylic acid functional group. Now, in organic chemistry, we represent the compound in different ways. First of all, you know about empirical formula, which is the simplest formula or something like the simplest ratio. We know about the molecular formula, which indicates the actual number of each kind of atom in a molecule. And we will look at structural formula, in detail because the structural formula tells us how the atoms are bonded to each other within the molecule itself. Okay, so in organic chemistry, the structural formula will come out a bit more than the other two. When drawing the full structural formula, there are some things that you will need to remember. First of all, every carbon can only form 4 bonds, every oxygen can only have 2, and every hydrogen can only have 1. Now, the full structural formula or the structural formula doesn't show the three-dimensional shape of a molecule. It just basically tells us how they are linked together. For example, whether they are linked in a single, double, or triple bond. Okay? So if you look at the example in the table, you have a few organic compounds. So you have propane. The molecular formula is C3H8. It tells me that there's 3 carbon, H, there's 8 of them, hydrogen, there's 8 of them. But how they are linked to each other is shown in the structural formula clearly. So for example, propene. So propene is in another family. Formula is C3H6. It only tells us that there's 3 carbon and 6 hydrogen. But how they're linked together, it is shown here. It is shown here. And you realize that there is a carbon-carbon double bond because it belongs to the alkene family. Now, the next one, propane 1-ol. You can ignore that 1-ol. It's also the same as propanol. Okay, we will talk about it another time, but not now. So C3H7OH only tells us what are the atoms, how many of them present. The structural formula will tell us how they are bonded to each other. Okay? In full structural formula, bonds are represented as such. A single line means a single covalent bond. A 2-line means double covalent bond. And 3-line means triple covalent bond. Let's look at one example. Ethanol. Ethanol has a molecular formula of C2H6O, which means 2 carbon, 6 hydrogen, and 1 oxygen. The structural formula written down shows us how they are bonded to each other, but the full structural formula tells us clearly how they are bonded. So the CH3 here is actually shown as this portion, the CH2 as the next portion, which I will show, and the OH as shown here. So this is the full structural formula. In summary, organic compound is the study of carbon compounds, and a special group of organic compound that only contain carbon and hydrogen is known as the hydrocarbon. Each family is called the homologous series, which is defined as a family of compounds with the same general formula and it has similar chemical properties. Every member of a homologous series will differ from the next one by a CH2 group. And members in the same homologous series will show a gradual change in physical properties such as the melting point or boiling point as the number of carbon atoms per molecule increases. Now, structural formula tells us how the atoms are bonded to each other within the molecules. And when we draw the full structural formula, we must remember that carbon must only have 4 bonds, oxygen must only have 2 bonds, and hydrogen must only have 1 bond. So this is the end of the introduction to organic chemistry. Thank you.